Yeah, good noon. In this session, we focus on exception handling, object-oriented exception handling framework in Java. Exception which represents a runtime error. Whenever the exception occurs when running the program, abnormally the program is said to be terminated. Suppose at line number 50, assuming that a runtime error is occurred. Because of that runtime error, the subsequent statements are not executed. That means that the line number 50, which indicates a runtime error, which abnormally terminates your program execution. Subsequent statements will never get executed. So we do like to handle the exception using object-oriented exception handling framework. For that, Java supports some keywords: try, catch, throw, throws, finally. Using these keywords, we can efficiently design a code so that the program should be protected from the abnormal program termination. So there are two ways of raising the runtime error. The runtime error can be generated in two different ways. One, user can generate the exceptions. This is said to be a custom exception or user-defined exception. Second, the system can generate exception because this is an object. Exception is an object, right? That object can be generated by the user or it can be generated by the system. However, the exception can be handled right properly using the exception handling framework with the help of keywords try, catch, through, throws, and finally. So before going to see right how these keywords are introduced in object-oriented exception handling framework, just to learn right the hierarchy of classes with respect to the exception handling. First one is throwable. Throwable is a superclass of all other exception classes. Already we have discussed the object. Object is the superclass of all other classes in Java. That means all user-defined subclasses are coming under subclass of category, right? Uh, in that, right, the superclass is object. Superclass of subclass. In that, with respect to exception handling, below object, you have one category called throwable. All other exception classes are coming under this category throwable. Further, throwable class is divided into two subclasses. One is exception and another one is error. Exception itself, a built-in class defined under a class called a throwable. Exception and error, these are some of the ways in which the runtime error are handled using the built-in classes. Below exception, we have some classes, say runtime exception. If you want to face any division by zero or invalid array indexing, negative array size indexing, right? This kind of runtime errors are defined in this class runtime exception. For example, arithmetic exception. Arithmetic exception, right? This is one a subclass of the runtime exception. All exception classes, that means all exception runtime errors can be handled through the user-defined coding. User coding can handle effectively the errors occurred that are a part of a subclass called exception, including the class exception. But there are some kind of runtime errors cannot be handled by the user. For example, in case when a stack overflow error is raised, right, unexpectedly. So this kind of some catastrophic errors cannot be handled effectively by the user-defined code. So Java runtime system, which results in some kind of this catastrophic errors, cannot be caught by the user. Now we are going to see right the general form of a try-catch block. Return try and catch. And the purpose of try and catch keywords are the program statements that you monitor for runtime errors are going to be blocked in a try block. The syntax is try, opening curly brace and closing curly brace. Within the part of opening and closing curly brace, the statements that you suspect for runtime error should be enclosed. Then following that, you need to define the object-oriented exception handler using the catch exception handler. Catch. Following that, within that bracket, you need to define the exception class name, then instance, then define the corresponding exception handler within that catch block. What we have to do when the runtime error is encountered. So when the runtime error is encountered within a try block, control is automatically sent to the corresponding catch exception handler. Thereby, the abnormal program termination is avoided. Right? Abnormal program termination is uh, avoided. For example, so in this class, the variables x and d are declared, and d is assigned a value, say 0. Int x comma d is equal to 0. We are evaluating the operation x is equal to 100 by d. Now what happens? 100 by 0. We cannot evaluate a quantity, right? This operation 0, right? Division by divide by 0 error. This results in a runtime error. This is not even a compile time error. For example, we are compiling the code Java C exception 1.java. Now compile time error is reported. While running the program, what happens? We can see the message exception in thread. What is the meaning of exception? Exception means a runtime error. Thread means, right, a single flow of execution. So far the programs we are discussing are all coming under a single threaded category. In right, what is the thread? Thread is the main thread. That means here in the main program we are facing the runtime error. So what kind of runtime error? Divide by 0, slash by 0. The slash by 0 is the error name. This error is defined in the class arithmetic exception. The class arithmetic exception is defined in a package Java's language package. So java.lang.arithmetic exception error name is divide by 0. Where this error is occurred at exception 1.main. What is exception 1? Exception 1 is the class name. The class name exception 1 in its main method, main, the corresponding program is exception 1.java and the 7 indicates the line number at which the runtime error is occurred. 1, 2, 3, 4, 5, 6, 7. This is the 7th line. So following that, right, what happens? Even you can have any number of executable statements. For example, system.out.println x is equal to x. The value of x is not printed because this line itself int x is equal to 100 by d. This results in a runtime error. Program is said to be abnormally terminated. So following the subsequent right statements, any executable statement will never get executed. So you can see the abnormal program termination. That means the default exception handler is handled. The default exception handler prints the state trace value. State trace means what is the name of the exception. Java.lang.arithmetic exception and the line number at which the runtime error is occurred. Then uh, the corresponding class name, create a method name. Class name is say exception1.java file name, method name, right? Which method results in a runtime error? Main method results in a runtime error. So these are the state trace value, which is to be printed by the default exception handler. So runtime error, which abnormally terminates the program execution. See the second program. Now have a look into this code. Int args is equal to 100, try is equal to 50, capital T, right? Try, since small t, try is a keyword. I have commented on the second line. Int xarray is equal to new int of 25 minus try. Now what happens? What is the array size we are going to create?
Negative, sir.
Negative index.
Array size will be negative, sir. So error will come.
Negative error will come. That error is a runtime error. This is not a compile time error because we cannot create a negative array. So array size must be a positive integer. So how the runtime error is reported? So first we see that exception 2. Exception in thread main dot or line dot negative array size exception. So from these errors, just learned that, right, arithmetic exception is a built-in class. All exception, all runtime errors are defined as the built-in class, right? So this is defined in the Java slang package. Negative array size exception. Here the classes, right, having, right, multiple words. Here the first character in each word is a capital one. Negative array A capital, N capital, size S capital, E capital. Negative array size exception. Line number is 7. This is the runtime error reported. In case if I have commented out this line, right, and removing this comment, can you predict what will happen now? How many runtime errors will be reported?
Sir, only one, sir. That
Only one.
Only one or
since divided by 0, only one will come.
one. Are you sure?
Yes, sir. Only one will come. Because after coming one, it skips the next step, sir.
Yeah, this is the ARGS, right, now results in a runtime error, that is a divide by 0 error. So subsequently, the following statements will never get executed since program is abnormally terminated. So in this case, there is no compile time error, and running the program, you will get this error, java.lang.arithmetic exception divide by 0 error. Now we have a basic question, right? Why do we control this runtime error? There is a question. In case if our program is having large number of lines of code, say LOC lines of code, say 5,000 lines, 7,500 lines. So that stage, right, it is difficult for us whenever this kind of runtime error is reported. We need to go through, right, the line number. Even line number will be reported, right? And in which method the line the runtime error is reported, right? Everything, right, that we can observe. But it's very difficult for us when the number of lines of code increases, and if you are not properly handling the runtime errors, then in some situations we cannot rectify that error. So to do that, it is better for us to control something, right, within the exception handling framework using try catch throw throws keyword, so that if there is a runtime error, that runtime error will be properly handled using the exception handling framework. Then there is a chance for us to execute the subsequent statements written based upon the logic of our code. So for that, right, what we have to do means we can introduce basically the try and catch blocks. To introduce the try and catch blocks, the logic is the program statements that is suspect for runtime error, that should be enclosed within a try block. Even in this example, right, this is one runtime error statement. We can predict it. This results in a one runtime error because this is a simple statement. We can introduce it by saying that this should be enclosed within a try catch block. But whenever we have a larger expression, larger assignment statement, so based on your runtime input values, right, you cannot determine, predict whether this expression results in a runtime error or not, right? So that stage, it is better for you to enclose those kind of assignment, complex arithmetic operation statements should be enclosed within a try block. For that, you try to follow this basic syntax. Try, opening and closing curly brace, try and catch are keywords. Within this try block, right, you can place the statements which are suspected for runtime errors. Following that, define the corresponding exception handler. Exception handler is this one, catch. Following that, you need to define the runtime error class name, the corresponding instance name, right? This is of course the instance name. For example, exception E, a throwable T, arithmetic exception say AE, negative array size exception, say some object. So likewise, our array index out of bounds exception, some object. Likewise, you need to design the exception handlers in such a way that each catch exception handler takes one class. So as of now, just think of, right, every catch exception handler is taking one class. But right, one exception, right? The exception in the sense that in the recent version of Java, right, you can place right multiple exception handlers within a single one using the OR symbol. Catch, for example, arithmetic exception, or negative array size exception, or array index out of bounds exception. That is possible. Later we see that, but it is a good practice to use one exception handler in each or one catch block, because here the definition is right, completely based on the instance of what kind of error is reported. Here you need to define some executable statement. For example, exception type 1, right? Error is runtime error is occurred. Next, we can define right the second exception handler, like switch right one to many. A single try can have several catch exception handlers. Following the last exception handler, assuming that one executable statement is there. Statement X. Now listen how the flow of execution of this try catch is taken place. Whenever there is a runtime error reported inside the try block, that runtime error is tested against the first catch exception handler. That means that runtime error is tested with the first exception class name. If there is a match, the corresponding exception handler will get executed. Remaining catch exception handlers are bypassed. Control goes to execute the next state, the next sequential statement, say statement X, following the last catch exception handler. Control will never come back to execute the subsequent statements following the runtime error statement inside the try block. Right? This is one case. In case when the raised error mismatches with the first exception handler, then control goes to check the second exception handler. The class name right should be checked for a match. If there is a match, the second exception handler alone get executed. Remaining exception handlers are bypassed. As usual, next the statement to be executed is statement X. In case right 1, 2, 3, etc. n minus 1 exception handlers are failing, assuming that in the last exception handler there is a match, means last exception handler will get executed. Subsequently, statement X will get executed. In the last case, assuming that the raised error mismatches with all these exception handlers, what will happen is control will be taken by the Java's default exception handler. Since there is a mismatch between the raised error and the exception handlers, Java chooses the default exception handler to terminate the program execution first. After terminating the program execution, right, it prints the corresponding state trace, or you can say by printing the state trace value, what runtime error is currently reported, then you can see that the abnormal program termination is taken place. This is the flow of order of execution of a try and catch block. So in our example, what we have to do means when you suspect these lines of code, right? These lines of code should be introduced within a try block, and you need to properly introduce the corresponding exception handler. For example, the first line here int x is equal to 100 by d. This results in a runtime error. Ultimately, the statement should be placed inside the try block. So including these statements. No problem, right? Multiple statements can be enclosed within this try block. Another rule, even if you want to check for a single statement for a runtime error, you need to explicitly use the opening and closing curly braces. Opening and closing curly braces are mandatory one, even to enclose for a single statement. Next, catch exception key. Just now we have seen A throwable is the superclass of all other exception classes. Below throwable, we are having two subclasses. One is exception and another one is error. Then exception is controlled by, right, having some runtime exception, right, subclass, and error which cannot be handled using the user defined code. For example, stack overflow cannot be controlled through the user defined code. Now, in case if you do not know what kind of runtime error will be reported inside this try block, you simply use the class exception, because the class exception or the handler exception can have the rights to capture this error plus any of the errors, right, are reported under the class of exception 1. So in this case, right, I show you first having the exception handler exception. Let us run the code exception 3 java c exception 3.java java exception 3. Now what happened? The error message is divide by 0 error java.lang.arithmetic exception slash by 0 after the try catch. See, have a look into this one. The value of e is printed after divide by 0 error. So after divide by 0 error colon, the instance e holds this value. Name of the runtime error java.lang.arithmetic exception divide by 0 error. In case if you know exactly right the arithmetic exception, this exception handler can be put as arithmetic exception, because divide by 0 error is defined in this arithmetic exception class. This stage what will happen means you are getting the same result java.lang.arithmetic exception. What is the difference between these two? Exception is the superclass of arithmetic exception. So the class exception can have the rights to capture any of its subclass exceptions, including the class exception. In case if you use negative array size exception, for example, negative array size exception. Now what happens? The raised error mismatches with the exception handler, because raised error is divide by 0 mismatches with negative array size exception. That stage what will happen means Java chooses the default exception handler to terminate the program execution. So you cannot see this message divide by 0 error. Instead, the default exception handler prints the state trace value. This is the case when there is a mismatch between the raised error and the corresponding exception handler. Here you can also specify a multiple exception handlers, catch exception handler 1, then second exception handler, etc. nth exception handler. So suppose we like to raise more than one exceptions within a try block, depending upon the input value, right? For example, have a look into this code. ARGS, command line arguments array. What is L? We are trying to get the command line arguments length, args dot length, array length. Now try, we are checking if L is equal to 0. In case if the command line arguments length is 0, we are trying to evaluate this expression 100 by L. This will not be printed, right? Because 100 by 0, which results in a runtime error, subsequent statement will never get executed. Assuming that when we provide one command line input, right? Now the argument length will be 1. When L is equal to 1, we are trying to create one array with 5 elements, x of 0, 1, 2, 3, 4. Trying to assign the 25th location in the array to some value, x of 25 is equal to 25. Now what happens? Since arrays in Java are completely different from C and C++, we cannot access any index outside of its range except 25, right? So this results in accessing the array index out of the range. So array index out of bounds exception will be raised. Here also you can see that this line will never get executed. So inside the try block, having two if conditionals, we have or two runtime errors, two possibilities of runtime errors based on the command line arguments length 0 or 1. Now we are trying the exception handler catch. First exception handler is this one, arithmetic exception. We are given the message say divide by 0 error plus e means right the object or the instance of arithmetic exception will get printed. Have a note of this one. In between the exception handlers, you cannot have any executable statement. Say here something y is equal to y plus 5 or x is equal to x plus 5 return will not be allowed. This results in a compile time error. Second exception that we defined is array index out of bounds exception. Here the words written A, I, O, B, E, right? All are capital letters. Remaining are small letters. Since this is a built-in class. The class is also a subclass of a superclass called exception. Now array index out of limits error plus E. Two exception handlers are defined. Following that we have the message after the try catch block. Now in case during the runtime we are trying to provide 0 command line arguments. That stage what will happen means command line arguments length will be 0. So we are trying to get this runtime error y is equal to 100 by m. 100 by 0 means now what happens? This results in a divide by 0 error. So corresponding runtime error is matched with right the first one itself, arithmetic exception. So in the order the match will be checked. This is checked with right this arithmetic exception. There is a match. So divide by 0 error is reported and the value of e say java.lang arithmetic exception divide by 0. After that what happens means first if results in a runtime error. The runtime error is caught in this exception handler itself. Then remaining exception handler is skipped. The next executable statement is after the try catch. Following that, control will never come back to execute the next executable statement following the try blocks runtime error statement. This is the case when we supply 0 command line inputs. Suppose we are trying to give one command line input. Say hi. This stage what will happen means command line input arguments length is 1. Now L is equal to 1. There is a match. We are trying to report right this error. Array index out of bounds exception. Right? Array index out of bounds exception. This exception is first matched with arithmetic exception. There is a mismatch. Then this one array index out of bounds exception. There is a match between this error and this error. So array index out of limits error and the instance value e is printed. Following that, the next sequential statement is after the try catch block. Suppose here instead of this arithmetic exception written, you defined some other exception name is during the matching process. There is a mismatch between the raised and the exception handler, then automatically Java's default exception handler terminates the program execution by printing the state
Sir,
trace value. Yes,
why can't it go to the next exception one, sir?
which one?
No, sir. When that exception is not matching, why can't it go for the next exception, sir? Arithmetic when arithmetic.
It actually, yeah, it goes for checking the next exception. For example, here assuming negative array size exception is defined. Assuming command line input length is 0. Divide by 0 error is occurred. This is first checked with a negative array size exception. There is a mismatch. Then it goes to check for array index out of bounds exception. Again, there is a mismatch between the raised error and this exception handler. Now, all catch exception handlers are tested out. Finally, the
Default.
Java's default exception handler terminates the program execution.
Okay, sir.
Understand?
Yes, sir.
Okay.
Sir,
Then when you define the exception handlers, yeah, yes,
so if we use
yes,
only one
sir.
exception, suppose if I don't know what exception will occur, in the both catch blocks, if I use exception,
Could not hear, your voice is breaking.
sir, are you able to hear now, sir?
Yeah, tell me.
Sir, array index out of bounds and arithmetic exception both will come under the class exception only, no, sir.
Yes,
So instead
yes,
of
tell me.
using two catch blocks, if I use only one catch block and if I give exception,
That can
or
have the rights
in the
to
both
capture
catch,
both of the exceptions. Yeah, both
okay,
exceptions will
okay.
be caught in the superclass exception. So that's what I
Suppose
am
if I
coming to
declare,
say. The next, yeah, tell me.
suppose if I declare both catch blocks in the both we have exception, after matching with the one, it won't execute second one, right, sir?
No, only one exception handler will get executed. So that's what I am coming
Okay.
to say the important point. The next one, when you define multiple exception handlers, the important rule is exception subclasses must be defined first, and then corresponding exception superclasses should be defined. In case if you are not following this rule, assuming that, for example, instead of arithmetic exception, we are using the class exception, right? Here, for example, here array index out of bounds exception means, right? What will happen means control will never go to execute array index out of bounds exception because in all cases the superclass, right, exception can have the rights to capture all of its. Let us check it in the code itself. Exception code. Exception code.java. Have a look into this one. I saved the file after changing this into simply exception. The second exception handler is array index out of bounds exception. Now, what is the meaning? Here, assuming that irrespective of value of L, 0 or 1, whichever is, runtime error is reported. That runtime error is checked with this exception class. What will happen? That runtime error will be caught in this exception handler. There is no doubt in that. Whichever is arithmetic exception or array index out of bounds exception are all runtime errors, right? Which will be caught in this exception handler. What is the use of array index out of bounds exception? The basic question. When will the control, right, comes to execute this array index out of bounds exception, or what is the relationship between these two? This is a superclass. This is a subclass. So when you define the subclass exception handlers following the superclass, control will never go for checking the subclass exception handlers, right? Always the superclass will be caught the corresponding exception handlers. So this results in a compile time error, right? So compile time error, have a look into this error message. Error, exception array index out of bounds exception has already been caught, right? So you are unnecessarily defined this array index out of bounds exception. This has already been caught in this exception handler itself. This results in a compile time error. So in the class hierarchy, while defining the multiple exception handlers, you should ensure that the exception subclasses must come first, and then you need to define the corresponding exception superclasses. If you fail to write redefine these things, automatically write what will happen means runtime error. Sorry, compile time error is the result. As we asked, right, the thing here in this example, I have illustrated one exception handler is array index out of bounds exception. Another one I defined as exception, that is arithmetic exception is not defined. Clearly, exception is a superclass. Array index out of bounds exception is the subclass. Subclass exceptions are defined first. Following that, the superclass exceptions are defined. So if there is a chance of capturing array index out of bounds exception, this will be caught in this exception handler. When there is a chance of arithmetic exception, since arithmetic exception is not even defined in this exception handler, this will be caught in the corresponding superclass exception. Understand or not?
Yes, sir.
Okay. Then nested try statements. We can also place a try block inside another try block. That is said to be a nested try one. Like for putting a for inside another for, right? We can define a try inside another try block. That is said to be a nested try. In this example, right, we have illustrated the nested try. Have a look into this code. Again, based on the value of command line arguments array, length of the command line arguments array, we are getting the value of L, right? If L is equal to 0, we are trying to raise this error. Divide by 0 error if L is equal to 0. In case if L is non-zero, part of outer try, right? That is, we are going to define one inner try. Inside this, we are checking if L is equal to 1. If L is equal to 1, we are trying to raise this error. Int x array is equal to new int of 5 and assuming that, right? That's why I am removing this comment. Int x of 15 is equal to 100. So after that, we are trying to access the 15th location in the array. X of 15 is equal to 100. Now, the inner try defines its own exception handler. Try must have at least one exception handler, right? As of now, based on the keywords try and catch, catch is said to be the exception handler. At least one exception handler must be defined for each try. So this inner try is concerned. This inner try defines one exception handler, say array index out of bounds exception, and the message is given as array index error. The value E is printed here. This is completely the scope of inner try and the corresponding exception handler. This closing curly brace closes the outer try. Outer try defines the exception handler, say arithmetic exception. Then one message is given, right? Arithmetic exception, the value E is printed. Following the outer try, we have given the message after outer try catch. Now have a look into write this code, how the flow of execution is taken place. Suppose the string argument, right? S command line arguments length S is right, SR is right, length is 0. Now L receives a value 0. When L receives a value 0, L is equal to 25 by L, 25 by 0. This results in a runtime error. Since this is a part of outer try, control goes to check for outer try's exception handler. Outer try's exception handler is arithmetic exception. So this stage, right, there is a match between raised exception and this exception handler. So you can see the message, this one, divide by 0 error, and the value E is printed, right? So first let us check this one. Java C exception 6.java. Java exception 6. See the result. Command line arguments length is 0. So what happens? This is outer tries runtime error. Outer tries runtime error, right? This exception handler is this one, arithmetic exception. There is a match. So this error message is displayed. Then you can see after the outer try catch. So always, whenever there is a runtime error reported in the outer try block, control goes to check against outer tries exception handlers in the sequential order. In case finally when there is a mismatch means, then what happens? Default exception handler terminates the program execution by printing the state trace value. Right? This is the rule. Outer tries exception handler testing. Now coming to the inner try. Suppose one string arguments length is 1. So in this stage, L is not 0. Control comes to execute this inner try. In inner try, L is equal to 1. Right? So in inner try, L is equal to 1 means here we are raising this exception. Which one? Array index, am I right? Array index out of bounds exception. Array index out of bounds exception. This is raised here. XOR15 is equal to 100. Inner try, first rule, inner tries exception handler. Now, inner tries exception handler, array index out of bounds exception, there is a match. So in this case, you can see the error message, array index error. Following that, there are no more executable statements, right? In the inner try, next outer try sequential statements, no more execution. You can see the message after outer try catch when you supply one command line input. Inner tries runtime error is tested with inner tries exception handler. There is a match. So the flow of execution is taken place in the sequential order as usual. Now here what I have to do, let me comment out to this line. XOR15 is equal to 100. Assuming that as we have given earlier, we are trying to provide one command line input. That stage L becomes 1. Having this line int q is equal to 12 by 0, 12 by 0 which results in a runtime error. This runtime error is first tested against the inner tries exception handler. Array index out of bounds exception does not match with this arithmetic exception. No more inner tries exception handlers are there. In that stage, what will happen means control comes out of inner tries exception handler after testing all exception handlers. Then it goes to check for outer tries exception handlers in the sequential order. This is the rule. 12 by 0 doesn't match with this array index out of bounds exception. Then it goes to check against this arithmetic exception. So the error will be caught in this block. Then you can see this message. Then after outer try block. So in this case, no abnormal program termination. So I need to recompile and run the file. Java C exception 6.java. Java exception 6. Then one command line input. Say hi. In this case, what will happen means control is coming here. It tries to execute 12 by 0, results in a runtime error. But this is not even matched with the inner tries exception handler. In case if there is a match between this raised exception with the inner try exception handler, that exception handler alone will get executed. Then normal sequential execution is taken place. If not, if the inner tries runtime error does not match with inner catch exception handler, then control comes out of this inner try block. It checks outer exception handlers in the sequential order. So this 12 by 0 error is caught in this arithmetic exception. So we have the message, right? Java.lang.arithmetic exception divide by 0 error after outer try catch. Another rule, when there is a runtime error reported inside the inner try, assuming that there is no match between the raised error with the inner try exception handler as well as outer try exception handler, ultimately no exception handler matches with inner tries runtime error or even outer tries runtime error. That stage, Java handles the execution of the default exception handler to terminate the program execution. This is a rule. This is a rule for right having nested try statements. Having any queries in this?
Sir, what if multiple errors are there in the same line of code, sir?
Multiple errors are there in the same line of code. You know, the evaluation is taken from left to right, right? And based on the operator precedence, whichever the runtime error comes first, corresponding runtime error is taken. Because in what order the expression is evaluated, that is important. So when evaluating the expression, which runtime error comes first, that takes more preference, more precedence. Only that runtime error takes an effect. Nested try, this is also same as the previous one, right? You can also define a method, user defined method. Inside that, right, you can introduce the nested try. On try, right, here outer try. This method can be called, right, inside the main method. There, the statement should be introduced within the try catch exception handler. This is similar to the previous one. Only the user defined class is introduced. Next one is a throw keyword. A throw, which is used to explicitly throw an exception. As the term, right, a word throw indicates that throw something. It seems unconditionally, right, we are throwing something. So as the term implies that a throwable instance. Throwable instance means the instance is thrown, right, automatically, right, to somewhere. So who is going to capture that throwable error means, throwable instance means the corresponding exception handler, right, will check there is a match between the throwable instance and the exception handler. If it's so, then that will be caught in the corresponding exception handler. Have a look into this statement. This is a syntax of throw statement. A throwable instance. Here, throwable instance must be an object of a throwable class or any of its subclass object. This is important one. So only the built-in exceptions, right? A throwable or subclass of throwable, right? Or some user-defined classes, right? Can be thrown using this throw statement, but you cannot define, right? Some throw some integer value, or throw some character, throw floating point values, or throw some string object, right? This cannot be used as exception names. The important rule of throwable instances. This must be an object of throwable class, or it should be any of the subclass object of a throwable one. How to create a throwable instance? A throwable instance can be created in two different ways. One, using the parameter of a catch exception handler. Catch, here you need to define the exception handler, then instance. This instance can be used as a throwable instance directly. Throw this throwable instance. That means throwable instance is same as the instance of the catch exception handler. This is one possibility. Another one, we can explicitly use the new operator, throw, new, then specify the exception class, then constructor if it is required. So in this stage, to this exception class, the throw statement throws the exception runtime error, so that throw new exception class or constructor means, right, uh, this constructor value is passed to the corresponding class name such that that instance is thrown out of the method or out of calling statement. Have a look into this flow of execution. So unconditionally, right, we are using throw statement. It seems throw something, the object or instance is automatically, right? So once the throw statement is executed, the throwable instance is thrown out of a method, for example. So following the throw statement, you will not have any executable statement. That means if you have any executable statement, that will never get executed. In Java, in case if you find any a statement which is not possible to execute, that results in a compile time error. This is very important statement in Java. In C and C++, for example, you might have seen return expression 1, return expression 2, return expression 3, etc. Multiple return statements can be given, right? May be given inside the function. Only when the first return statement is executing, control is returned to the corresponding value. Remaining return statements will never get executed. Where in Java, if you write the same in Java, once the first return statement, even you can have some return statements that will never get executed. Java compiler treats those lines as unreachable code. If you find any unreachable code in Java, that results in a compile time error. So very important thing, following the throw as the executable statement should not have any executable statement. For example, here, throw new null pointer exception, right? Unconditionally, one null pointer exception instance is thrown out of this method, which is placed inside the try block. Following this, if you try to use any executable statement, is the statement results is the statement right result in an error means yes, the statement results in an error because following the throw executable statement, you should not have any executable statement. This results in a compile time error. So now have a look into the logic of throw. Unconditionally, you are throwing some exception out of a method. That is a simple logic. For example, in this class, a method is defined. Inside this right, in the try block, we are unconditionally throwing an exception. So where will be caught mean it will be caught right in the corresponding exception handler during the match. So throw new null pointer exception. You can use any exception class name, right? And the exception class name must be a throwable class object, or you can use any subclass object. Here, for example, null pointer exception, right? That comes under a category of throwable, since throwable is a superclass of all other exception classes. Even you can use arithmetic exception, array index out of bounds exception, something, constructor null pointer error, something. So inside the try block, this message gets executed inside method. Unconditionally, right, you are throwing the null pointer exception. But logically, it seems that after this right, you try to have some executable statement. In that right, based on some conditional check, try to introduce the throw. So when there is a null pointer error occurred inside the code, logically control through using if then else statements, then introduce a proper throw statement. But this example shows the simple usage of throw statement. So throw, a throwable instance. A throwable instance is created using the new operator. Throw new, then exception class name, constructor value if it is required. So what happens unconditionally, right? This throw statement throws this runtime error, null pointer exception. Who will catch this exception? The exception handler say catch. This null pointer exception will be matched with this one null pointer exception. So there is a match between this raised or the error that is thrown and the corresponding error defined in this exception handler. You can see the message written constructor null pointer error ne is plus ne. The instance ne is printed. After that, if you do not use throw ne, no problem, right? So following is a try and catch after the method call, next sequential statement is executing. But inside the main method, the calling statement itself placed inside a try catch block. Calling statement is this class object name dot method name. This class object name is say th, and the method name is just method th dot method. Since th object name dot method itself placed inside the try block, right? This can be used for the corresponding exception handler. So define the exception handlers. In the exception handler, here we are writing say null pointer exception. Now here in null pointer exception, this is already caught here. The null pointer error thrown inside this method is caught here. If you want to rethrow this error to the calling place, who is the caller? Main method is the caller. Th dot method is the caller. So to rethrow this exception to the calling place, what you have to do means, again you can use this option, throw any, using this general form. Throw, throwable instance. Throwable instance is here, NE. NE is a throwable instance. What is throwable instance? A throwable instance is created using this exception class name in the exception handler. Exception handler, then throwable instance. So throw NE rethrows the throwable instance to the corresponding caller. Who is the caller? Th dot method is the caller. Since the caller is placed inside the try catch exception block, you simply think that th dot method invokes this method. Inside the try block, runtime error is reported. Runtime error is checked against the exception handler, and the exception handler catches the corresponding runtime error. So the message is printed. Sequential execution is taken place. So throw NE. We are trying to rethrow an exception to the calling place. In case if there is no throw NE, no problem, no runtime error in the method call. Since the runtime error is already defined as a part of the method that is captured in this exception handler. Having throw NE, what will happen means, just think of that runtime error is again resent to the calling statement, that is th dot method. Just think of th dot method results in the runtime error. That runtime error is this one, null pointer exception. Now this null pointer exception is checked against its own exception handler. Say in the catch block here, raised exception is null pointer exception. This is matched with this null pointer exception. So what will happen means, the error that is rethrown from this catch exception handler is caught again inside this exception handler of main method. So this runtime error is reported and will be caught in this exception handler. You can see the message in main catch. The value of the throwable instance NE is returned to the main method and will be processed in this exception handler. Then you can see the message end of main method. This is the purpose of the throw keyword. Throw keyword manually throws an exception out of a method. This can be controlled through some if, for, some while statement. So logically you can write the purpose of a throw. To throw the throwable instance, a throwable instance should be created using the new operator like this, or it can be created using the parameter of a catch class that can be directly passed as a throwable instance. So in this example, have a look into the flow of order. Throw object th is created, th dot method is called, control comes here. First we can see the message inside method. Following that, the runtime error is explicitly thrown out of this method, but this will be caught in this exception handler. So match null pointer exception matches NE is instance NE is printed in the second line. Then the statement throw NE rethrows the same runtime error to the calling place. Calling place is th dot method. It seems that th dot method again results in a runtime error. That runtime error is null pointer exception. This is matched with this exception handler. So you will never see the message after calling th dot method. In case if throw NE is commented out, then you can see the message after calling th dot method. So in this case, highlighted statement results in a runtime error. This will be processed in this exception handler, null pointer exception. So the third line, you can see the message in main catch, the value of n, the null pointer exception instance is printed. Then at the end of the line, right, you can see the message end of main method. This is the purpose of throw. To use of throw, you need to follow the syntax. Throw throwable instance, throwable instance is created using this rule. Having any queries in this?
So what is the purpose of constructor here, sir?
What is the purpose of constructor? Here constructor 1 minute. What we have given constructor null pointer error. Check the message, right? Null pointer exception, constructor null pointer error. Because here the null pointer exception is a class, right? The class is having one parameter, a constructor, that is a string argument constructor. So we are invoking the string argument constructor, say a constructor null pointer error. That message is displayed whenever you are printing the value of any. So here you can see the message, constructor null pointer error. If you do not specify the string parameter value, no problem, right? Here you cannot see that message, null pointer, constructor null pointer.
Or if we don't throw any inside the catch null pointer exception any method of the class, then it won't be displayed in the main class.
This one, if there is a mismatch, you are asking what will happen.
No, sir. Inside that method, we have throw any. That statement is there, no, sir. If we are not, if we are commenting out that line, then the error won't be caught inside the main class, no, sir.
Yeah, if this is commented out. Now what will happen?
Inside the catch method, sir. Inside the catch. Throw any.
Which
if we
one?
comment out
This throw any.
Yes, sir. If we
1 minute, actually. If throw any is commented out, this runtime error will be caught in this executable statement. Then who is the caller? th.method. The runtime error is processed in the method itself. There is no runtime error reported in th.method. That means the runtime error is not resent to this th.method. Subsequently, you can see the message after calling th.method. Let us check that. So right, what happens after calling th.method, right? After the 2 lines of output. Then you can see end of main. This exception handler there is no chance because no runtime error is reported inside the try block. Try block finished its execution completely.
Okay, sir.
Having any other queries?
Sir, so here throw is to throw the exception explicitly, sir.
Explicitly, yeah, that is a question. When to use throw, that is a question, right? Even here, that's what I said. Here, you try to use logical statements in case the condition is satisfied, right? If then you can place a statement through new null pointer exception. This is just to illustrate basically the syntax and working of through keyboard. I post these right in the classroom. You please try to go through these things and try to work with them, right? And so many built-in exception classes are there. Negative array size exception, illegal access exception, instantiation exception, string index out of bounds exception, array index out of bounds exception, arithmetic exception, class not found exception. So many runtime errors are reported, right? The thing is, right, I ask you to go through these exceptions. First, you should understand when this error is actually raised in the code. For example, in the first example we have illustrated, right? You know what is the meaning of this one, divide by 0 error. In the real situation, when the divide by 0 error is occurred because of this statement, x is equal to something, numerator by denominator becomes 0. And another one, you know that if the array size is given as a negative value, you know that the negative array size exception runtime error is reported. When the array index right goes out of the range, array index out of bounds exception is rising. Then negative array size, right? Giving the negative value, right? A negative array size exception. Likewise, when the string index is out of range, string index out of bounds exception is rising. Likewise, you should know what is a null pointer exception. In this example, just we have thrown this exception, but you should understand when is the null pointer exception rising. without the usage of this throw new something, right? Already in one stage, right, we have encountered, right, the null pointer exception, right? When we work with classes and objects, you try to recall that in the normal, right? I ask you, you have to try these exceptions in the normal circumstances, how this kind of runtime error is reported. That you should understand first. Then, how this runtime error can be efficiently handled through the exception handling framework, say try, catch, throw, throws, finally keywords. That is the main aspect of learning object-oriented exception handling framework, right? Then only in the larger project you can efficiently, right, introduce the proper exception handling framework to avoid the runtime errors. Okay, please go through this and ask me, right, if you have any queries. I already said you, right, to go through the packages and interfaces concept, right? I have posted some videos. Go through that, right? And if you have any queries, right, you try to ask me. I will clear your doubts. Okay, thank you very much. We will discuss in the next session.